Welcome, dear students. In today's lecture, we are going to cover up the topic that is computerized wheel alignment and balancing. Just I would like to give you the brief summary that what we are going to cover up today. Starting with the initials means what the important terms are there in wheel geometry. That is what the caster angle is, what the camber angle is, and uh, thereafter caster camber and toe in toe out and the steering angle inclination. What that these terms are there and how they are adjusted and what the importance of these terms are there. And thereafter we will go for the balancing because in the syllabus itself a term is there that what is the computerized wheel balancing is there. Although the terms which I have mentioned earlier means the terms, all these terms which I have mentioned are for wheel alignment only because whatever steering geometry angles we are dealing, whether it is a caster, whether it is a camber, whether it is a toe in toe out, or whether it is steering angle inclination, that is only for wheel alignment. For wheel balancing, we generally used to remove the wheel and rotate it on a machine. And after rotation on that particular machine, we used to get the weight which you have to place. So we'll cover up the topic that how the wheel balancing is done. I will show you some videos also because some videos are recorded by me. So we will cover up this topic and we are going to start with it. Lecture. We are going through the important terms what are included for wheel alignment because I have told you that the wheel alignment is a different thing. For that, the steering geometry angles are dealt, and for most of the cases, the angle which is deal is the toe in toe out. Means when you go for a shop for wheel alignment, they generally used to change the toe in toe out angle, and the remaining angles are there, although they are important, but they are very seldom changed. That are the caster angle, the camber angle, and the steering axis inclination is not able to change because that is the factory made feature. And what the balancing is there because when we used to have a new wheel in our vehicle, we used to have a balancing of that wheel. We used to put some weights, but that's a different thing. Means we have to cover up two things today. One first is the wheel alignment, and the first one is the wheel alignment, and the second one is the wheel balancing. Means wheel balancing we have to also cover. Two things we have to cover. For wheel alignment, we should know that what angles are there in the steering geometry. Starting with the first angle, that is the caster angle. The caster angle is that what the angle the kingpin axis is making with the vertical. It is seen from the side because although this figure they have shown over here, but the right way is to see the vehicle from the particular side, either from the left side or right side. And when we see the vehicle, the vertical axis is this, and the steering axis is this. Means the kingpin axis is this, and what the included angle is there. Means this angle is called the caster angle. This can be shown to you by a video also because a video I have downloaded for this that how it is being done. The video is over here. So starting with the video, you can see that how the caster angle is here. The caster angle is being shown over here. In the video, it is being shown that the caster angle, the steering axis, that is the kingpin axis, if it is moved towards the backward side, means toward the engine side, then it is the positive, and if it moves toward the front side, then it is negative. So this is being shown over here. Then it is positive. Forward, then it is the negative. That is being shown over here. And what else is there? If we start after the steering caster angle, the next angle which is this, because the caster angle I have told you already that when it is positive, when the axis, the kingpin axis used to be at the back side, means it has from the vertical position it has gone to the back side, engine side, that is positive, and if it is the front side, that is negative. And the basic purpose of caster is to aid directional control to the vehicle because when we steer a vehicle, the front wheel are generally steered, and that control on that mechanism is generally obtained by that caster angle itself. The caster can be seen in two-wheelers also, because in bikes also we can see the caster angle, and it is dependent on the caster angle that how much we are able to steer with less effort. To cause vehicle to return to the straight ahead position means when vehicle is steered, it used to get returned at the straight position automatically, and that is dependent on the caster angle. To offset road crown pulls, that is for this it is also important, and that's why it is being discussed that for caster angle when it is positive, it helps to wheel travel in straight line. Now we are going for the what negative caster is there. Means negative caster means from the vertical axis, the kingpin axis is at the forward side. Means it has gone certain angle to the forward. I have shown you in the video also. Then when it used to go to the forward side, then it is negative. It is the plus side, and when it is forward side, then it is the negative. Now what used to happen that the tilt angle of steering knuckle towards the front, that is being written over here. Wheel is easy to turn, because in certain bikes also we used to see this types of angle in bicycles also. Wheel will tend to swivel from the imperfections of the road, and caster is measured in degrees. What the caster angle is. Now we are coming to the second important term. The second important term is the camber angle. The camber is the inward or outward tilt of the wheel. For seeing the camber angle, because for caster we were standing at the side of the wheel, the vehicle. We are standing over here. But for seeing the camber angle, for seeing camber angle, we have to stand in front of the vehicle. Means from the front side we have to see the vehicle, and if these are the wheels, two wheels of the front wheel, we can see when we are standing in the front side. We can't see by this, because for caster we used to stand at the sides, and for this we have to stood in the front side. The caster means that what angle the wheel is tilted towards inward direction or outward direction, that is being shown. If it is the inward direction, means towards the vehicle, then it is negative, and if it is outward, then it is the positive. This can be shown to you by video for camber angle itself. Now it is being outside or inside. This is being shown over here, and from video we can see that what angle they have mentioned. This is the caster they have shown. This is the camber they have shown. The wheel is going outside, means this is generally for the weight consideration it is being done, and for uniform wear of the tire also, because what used to happen when a heavy loading vehicle used to drive, or when the vehicle is running on the full load condition, a negative a certain amount of camber is given to the wheel itself, and when the vehicle is loaded, the wheel automatically used to get vertical. This feature is given for uniform wear of the tire also. So you can see that when the tire is outside, then it is positive, and when it is inside, then it is negative, which is being shown over here. And the camber is inward or outward tilt of the wheel and tire assembly when viewed from the front of the vehicle to prevent tire wear on outer or inner treads. Means because if the wheel is not straight, then it will get weared on the outer side or inner side. When it will be loaded, that will automatically get tilted. So before loading, we used to tilt them, and as soon as the vehicle used to get loaded, the wheel automatically become straight. That's why uniform wear we used to get. To load the larger inner wheel bearings, means the inner wheel bearing should be loaded more. The aid steering by placing vehicle weight on the inner end of the spindle. Now these are of two types. I have already discussed the positive. In positive, we use the vehicle, the tire used to get tilted to the outer side, and for negative, it is the inner side. The angle they have also mentioned that the angle, the range will start from 1/4 of degree to half of degree to compensate the weight. That I have told you earlier also, that when you see a loading vehicles or other types of vehicles, for compensating the weight, these types of camber are given, and these tire used to get straight when the load is given. Means become vertical when the load is given. Now the toe in toe out, because the toe in toe out feature, we have to see the vehicle neither from the side nor from the front. We have to see from the top. In this type, we have to see the vehicle from the top itself. And when we see the vehicle from the top, suppose we are seeing our own toe, means our own feet we are seeing. And if these are straight, means neither toe in nor toe out. And if they are moved outwards, means if they have moved them slightly outwards, then it will be toe out. So this is being shown that there are two conditions. One is toe out and other is toe in. And we used to measure the angle with the when we see from the top side the straight line, what angle the tire is being having, the what angle it is having. And toe out wheel are farther apart at the front than the rear, means the wheel at the front side are farther apart. This is being shown over here as compared to the rear. And toe in, the wheel are closer at the front, means the wheel have tilted close in the front, and they are further in the back side. And why it is required means toe in toe out. The rear wheel driving setting, the front wheel tends to toe while driving. As the tire roll over the road, they are pushed rearwards, causing the tire to turn outwards. Means when the vehicle used to run, whether you have given the toe in, but as soon as the vehicle run at a particular speed on the highway, it will automatically become straight. Meaning because the tires are moved outwards, they will be moved outwards. That's why initial slight toe in is given. And the toe in range is also given, that what much toe in it is being given for to compensate this. And what settings are there are shown over here. The front wheel propel the vehicle. As we know that most of the vehicles are front wheel driven. They push forward by the engine torque. This push causes the wheel to pin inwards. To compensate this are set toe out. Means in the front wheel drive vehicle we used to give the toe out. Certain amount of toe out is given if the vehicle is front wheel driven. So that's why they are set at toe out for this. And toe in is given because when a vehicle used to get a certain speed, then they are adjusted by giving a certain amount of toe in. Now the third portion is the steering axis inclination. Means what angle this kingpin axis is making. This is seen from the front side. Although this axis was studied in the caster angle also, but in the caster angle we were seeing that it is how it has moved in this direction. But now we are seeing that this direction angle, what angle it is being given. This is being shown through a video also, that what angle the axis is taking. Now this is the video. This is being shown over here. This is the position they have shown, that what angle it is giving, and this again it is being given. The proper the steering axis inclination is there, the lesser the caster angle will be there, because and more stability of the vehicle will be there, and vehicle will be more stable. So that's why this feature is given at the initial designing of the vehicle itself, because this can't be changed. And always an inward tilt is given, means the steering axis is tilted from vertical direction towards the inward direction. Not a tire wearing angle, not adjustable. That's why I have told you that it can't be adjusted, because it is adjusted by the industry itself, and it used to control the caster angle also, because by adjusting it the caster angle can be reduced. Must replace part if not correct. If it is not correct, then we have to go for the replacement, because it is a factory installed system. And adjustment of caster angle. Caster is adjusted by moving the control arm so that ball joint moves towards the front or rear of the vehicle. Means moving the control arms it is required. And for this particular shims, adding or removing of shims are required. Means we have to show one video that how it is being done. And by this caster angle is adjusted. Means the angle which I have shown you, the caster angle, that is being adjusted. The shims are shown over here also, means that the last video I can show you how the shims are adjusted. Now this is what the shims are there. In the video they are showing that how the shims are adjusted. Now this portion they have to adjust for tilting the wheel either to the means this axis is to be tilted with respect to this. They are showing in this video. And the second angle, which is the camber angle, is there. And how this is being adjusted is shown. For this camber angle adjustment, a centric ball joint is there. For this, by adjusting it, the camber angle is adjusted for the vehicle, and the tire is either out, camber out, or either it is from the vertical position, either it is either tilted to the inward direction or either to the outward direction. The last thing, that is the toe in toe out. This is generally being done at wheel alignment, because I have told you, although the angles are three, although the angles are four, but out of the four, one can't be adjusted. So caster, camber, and toe in toe out are adjusted. But out of these, most generally the toe in toe out they used to adjust. They generally used to unwind a screw from the tie rod. This is being shown over here. Screw is there in the tie rod. They used to open it. When they used to open it, the wheel used to move outward, and when they used to tight it, the wheel used to move inwards. This is being shown over here also by opening and closing this. And where this screw is in the tie rod, this is the tie rod, and this portion I was telling that they used to open this screw, means either this screw or this screw, more probably they used to open, and when they open it, the wheel used to go outside, means outer side, and when they used to tight it, they again the wheel used to go inner side. This is being shown over here, and this is the complete geometry, that how the steering wheel, the steering gear, the rotary motion, and again the rotary motion by pitman arm is converted to the reciprocatory motion, and by the reciprocatory motion of this rod, a complete track rod, and connected to the tie rod, we used to get the steering either to this direction if the vehicle is moving in this direction, or either in opposite direction if the vehicle is moving in this direction. Means by the linear motion we used to convert it. And hereafter we will cover the next topic, because that was the alignment portion. That was the alignment. And the second portion which I have told you was the wheel balancing. The wheel balancing is a different thing, because in this we used to remove the wheel from the vehicle and used to rotate it and see that what balancing weights are required. And wheel alignment is a different thing. In the wheel balancing, why it is needed? The wheel balancing machines for car wheel is designed for automatic measurement and correction of dynamic balancing. Normally the balancing machine is integrated into wheel assembly line. Means the automatic machines is used for balancing this. And what is that? Why is wheel balancing required? Wheel balancing is the operation performed in order to attain uniform traction and to avoid vibrations in automobiles by addition of balancing weights. Means certain weights are added to avoid unbalanced forces, because when a wheel we used to purchase, it used to have certain unbalanced weight, either in grams or certain grams we used to have, and up to that gram limit we used to put the weights on the wheel itself and used to balance it. When to balance a wheel, vibration in the steering wheel at certain highway speed means we are having the bubbling or vibration in the wheel. The vibration in seat or floorboard at certain highway speed, scalloped or cupped wear, means in the tire we see certain types of wear, means this is being shown to you over here. Means cupping is there, or scallop is there, or means side wear is there, because the wheel is not uniformly getting wear. Then we used to do it, and at this portion we used to do it. And what else? Scallop or continuous series of circular alignment on or angular projection formed a border as of cloth or metal or rubber. And this scallop is shown to you, and the cup is also shown over here. And what else? The dynamic balancing. Dynamic balancing describes the forces generated by asymmetric mass distribution when the tire is rotated, usually at high speed. Means the tire is rotated and the asymmetric mass distribution is there, means the mass is not uniform throughout the rim or throughout the tire. Then a certain amount of mass is added in the wheel itself. In the tire factory, tire is mounted on the balancing machine. The assembly is accelerated up to certain RPM, and sensor measure the force of unbalanced tire weights. This can be explained to you through video also, that I have downloaded one video and these weights are shown. What weights are placed. So coming to the video itself, this video I have made myself, and video of balancing. In the wheel balancing, this video is recorded by me, and you can see they are using a wheel and they are mounting on the automatic wheel balancing machine. The starting with the they used to uh, tighten a bolt that is being shown over here, so it get firmly fixed, because by rotating our mass we used to get to know that what unbalanced forces are there, because uh, if any certain unbalanced force is there, that is to be removed. Starting in the start, they are removing the weights, because whatever weights are there, these types of weights are used in costlier vehicles, because they are, the rim is also a bigger size, as well as the weights are pasted, so that's why he's removing. With this, he should also remove the small stones also, because if stones are there, then in the threads, then it will cause certain problem, because in the procedure it is being explained to you that the means starting with the procedure, we have to remove all the stones. The wheel is to be fixed to the spindle that was fixed to the spindle that was shown to you. Quick cone lock, the cone lock was shown, that was used uh, for fixing the tire to the machine. Machine is switched on and the RPM is set, the rotation spindle is stopped, and whatever weights they have mentioned through the machine have specified whatever weight that we have to place. Generally, the weights are of these types, means these are placed in the rim itself, but in case of costlier vehicle or when the rim size is very much higher, then those weights are used, which I am showing you in the video. Similar balancing is done for other rotating things also, because a slight portion of unbalanced force will cause a big thing, because we know that the centrifugal force, if it is unbalanced, will be troublesome. So that's why the balancing is done for other items also, because for electric motors, fans, turbines, the balancing is being studied, means how much, whether the balancing weight is within the permissible limit or not. So in the video, it is being shown that how the balancing is done. Firstly, the remove all the weights. He is removing all the weights, and after removing the weights, these are the weights. Fresh weights are shown to you, and this will be pasted as per the prescribed structure of the machine. Now starting, initially the computer is showing the OK. As soon as he put the lever down, it automatically used to rotate. The wheel is to start rotating, and after attaining a certain speed, it knows that what unbalanced force has created the problem in the wobbling or centrifugal force. Now it is showing that 25 grams is to be placed, and the location is also shown on the screen. Means here we have to place the weight in the inner side. The inner side and outer side, two are mentioned over here. One is the inner side and another one is the outer side. Means the inner weight is 25 and outer is 0 grams. Means this place we have to place. So in the wheel also we have to see that whether this location is mentioned or not. So as soon as the wheel will stop, it is not stopped. As soon as it will stop, a light will blink, because it is showing that a light will blink over here. And in the wheel we will see whether the light is blinking or not. We see a red light over here. You can see. At this portion we have to place the weight, and at the inner portion or outer, at which portion we have to place, either in the inner or either in the outer. That is mentioned in the screen itself. Now he will place the weight, the fresh weight he has taken, and the quantity that is prescribed by the machine will be used, and he will paste that much amount of weight at that particular blinking light. He has taken the weight, and the combination of weights can be used if you are not having that particular weight, then a combination of weights can be used. Now he is fixing the weight. At the exact position the weight is being fixed. Now it is being shown over here, the exact position. The weight is being fixed over here. The light is also blinking at that point. Now again we will start the machine and we will see that what will happen. He is starting the machine, and you might be knowing that who is recording that video, one of our faculty. and when he rotated the machine, he get okay at both the points. Means again, when the machine was rotated, the wheel get rotated, we get okay. The reason behind this is that we have placed the assigned weight over there. This is how the wheel balancing is done overall, and how the weights are placed, because why it is necessary. And this is the machine which is being shown, and this is the cover for safety, because when wheel is to rotate, the safety is required. This is the conical lock that was discussed, that we have to, the quick cone lock is being shown over here. So that's why a separate image is shown over here, that for fast removal of the weight of the tire, a quick cone lock is used, and all the steps are shown over here. The weight is again shown to you, that what weight is, and the weight is also specified on, engraved on the weight itself. We use certain combinations of weight if the value is more than the limits, and if we are not having the particular weights. One thing is important, that in fact the material is mentioned over here, means earlier the lead was used, now the zinc is used. But one thing is important, then when the vehicle is of accidental case, means when the rim has damaged a lot, then what used to happen, we used to replace the rim itself, because we can't keep on placing these weights, means increasing the size of these weights, because this particular limit of this weight is there. So do search on the net also, that what the limit of balancing weights is there, because up to certain limits the balancing weights are placed on the wheel rim, but after, when the limit increases, we have to replace the rim itself. Now this is how the two topics are covered today, because this was not a single topic, although we used to think that it is a single topic, but there are two topics. One is the balancing, means computerized balancing, and another one was the wheel alignment. Alignment means all the angles. This is concerned with the angles, and this is concerned with the rotation and masses. Any doubts are there, then you can ask. And thank you. This is for today's.